This video is about special right triangles and the side relationships that show up in two specific right triangle situations. So the first thing that we're going to do here is try to rewrite the hypotenuse y in terms of the side length of x. And I'm going to do that by starting out with the Pythagorean theorem. So the two sides, x squared plus x squared, is going to be equal to y squared. Combining like terms on the left-hand side gives me 2x squared equal to y squared. And because I'm trying to get y by itself, I'm going to take the square root of both sides, which tells me that y is equal to the square root of 2x squared. And since I can't take the square root of 2, but I can take the square root of x squared, this tells me that the hypotenuse y is equal to x times the square root of 2. So this is the length of the hypotenuse in terms of x for any 45, 45, 90 triangle, which is a isosceles triangle, one of our special rate triangles. Here's the relationship that's always going to show up regardless of the length of x. If you have a special right triangle that's an isosceles triangle with two 45-degree angles, you will always have your side lengths of x, and your hypotenuse will always be x times the square root of 2. Another special right triangle that we have is a 30, 60, 90 triangle. So in this case, I have a degree measurement of 30, I have a degree measurement of 60, and so your side lengths are going to be x times the square root of 3, and 2x. And it's very important to notice that x is across from the 30-degree angle, and x times the square root of 3 is the opposite of the 60-degree angle. So I'm going to use this as in an example. So here I have a 30, 60, 90 triangle. The hypotenuse is 8. I'm going to label this side as x based on the special right triangle rule we saw on the last slide. And 8 is equal to 2x. Let's actually make that look like a 2. Gracious. So since 8 is equal to 2x, what I'm going to do is solve for x, and then I can use that to find the other side of the triangle. So dividing by 2 tells me that the value of x is equal to 4 units. So I have that as one side of my triangle. And if I label this side of the triangle y, the value of y is equal to x times the square root of 3. So that tells me that the other side y is 4 times the square root of 3. So that would be the other side of this triangle. And I have one more example that we're going to do together in this video, and it's dealing with a crosswalk warning sign, which you see a picture of right here. Our goal for this question is to find the area of this crosswalk sign. We know that the area formula for a triangle is 1/2 base times height. And so I need to know the base of this triangle and the height of the triangle. This is the entire base of the triangle, which is 1 meter. So I have that already. What I do need to find is the height of the triangle. And in order to do that, I can use the 30, 60, 90 rule. I have an equilateral triangle. So that tells me that this angle here at the bottom is 60 degrees, which makes the angle at the top 30 degrees. So I'm going to redraw this, just half of the triangle over here. So there's my 60-degree angle. And this hypotenuse is 1 meter. taking half of this entire base would tell me that this piece on the bottom here is 0.5, that adjacent side. So if 0.5 is the value of x, based on my 30, 60, 90 rule, 2x, which would be my hypotenuse, would give us 1 meter. And the height in this case would be 0.5 times the square root of 3. So this is going to be our height value. So I can take that information and substitute that into the area formula. So I'll have that the area of this sign is 1/2 of the base, which is 1, times 0.5 square root of 3. And that whole piece can be typed directly into your calculator. And you'll get an area for the sign, which is about 0.4 square meters.